In this series of videos we're going to look at reducing an algebraic fraction to its simplest form. That means that if we have a fraction that includes algebraic terms, we know the strategies of how to simplify them. First we're just going to look back at a few examples of how to simplify regular fractions. Here we've got the fraction 60/100, 60 over 100, or 60 divided by 100. Your strategy when you're dividing fractions is you need to find the biggest number that divides both the top and the bottom number. In this instance, the biggest number that divides 60 and 100 is 20. For the purposes of the following examples, so what we're going to focus on is that we can write 20, or we can write 60 as 20 times 3, and we can write 100 as 20 times 5, because they can both be divided by 20. We now have two things that are multiplying each other on the top, two things that are multiplying each other on the bottom. And this is really important. When things are multiplying, that is when we can simplify. Okay, so the 20 here and the 20 here can be simplified, which will leave us our final answer as 3/5. Okay, I'd be expecting you to be able to go straight from this line to this line here. If we're to go for one more example, let's go 72/81. Top and bottom can be divided by 9. So if we divide 72 by 9, we would get 8. If we divide 81 by 9, we would get 9. 8/9. You must be confident in simplifying these sort of fractions before you go any further. The basic rules for when you are simplifying algebraic fractions are: if you can factorise, factorise first, and then you can only cancel out things that are multiplying each other on the top and bottom. Okay, you can only cancel out things that multiply. So for example, if we had an expression that looked like this, x plus 8 over 8, we cannot do the following step. We cannot cancel this 8 and this 8. We can't cancel those 8's because of this multiply in here, or sort of this add in here. We can't do that. Okay, so that doesn't work. If we had the expression 8 bracket x plus 8 over 8, what we have here is that we have 8, which is multiplying this full bracket. Okay, so 8 is multiplying this full bracket. So we've got 8 times x plus 8, and we've got 8 on the bottom. This is just essentially 8 times 1. In this scenario, we can simplify it because this is multiplying the top and this is on its own. And that would leave me with the expression x plus 8. You can only simplify algebraic fractions when things are multiplying. When we've just got adding, we can't cancel out terms at the top. Okay, in the following example, we've been asked to simplify 5a over 7a squared. Okay, the first thing we have to do is we need to see, can we factorise? Is there a common factor? Is there a difference of squares? Is there a trinomial? No, not in this scenario. Okay, so first thing to note though, we've got an a here and an a here. Okay, so that might come in handy when we are going to be going about simplifying this. First thing to note, 5a means 5 times a. 5a does not mean 5 plus a. 5a means 5 times a. 7a squared means 7 times a times a. So notice on the top we've got things that are multiplying, on the bottom things that are multiplying. I can only cancel out the things that appear on the top and the bottom. So I've got 1a here, that can cancel out with 1a here. It cannot cancel out with both a's, I can only cancel out what I've got. So after I've done that, I'm just going to write down what I have left. So I'm going to have 5 over 7a. Okay, in this example I've been asked to simplify 30xy over 60yz. Okay, first thing to notice here, we've got letters in common, so this is looking promising. But we must also be aware of our numbers as well. The numbers can simplify just as before in a regular fraction. What I'm going to do first off, so I'm going to rewrite this in the form. So at the top it's going to be 30 times x times y, and that's over 60 times y times z. Okay, let's look at our numbers first here. Okay, can these both be divided by something? Yes. What's the biggest thing that divides them both? Is 30. So 30 divided by 30 is 1. 60 divided by 30 is 2. Okay, so I've now worked with my numbers, and then I'll look at my letters. Everything's multiplying, so I can cancel down. I can cancel this y with this y. So writing it in the form, all I've got left at the top is 1x, but in algebra we don't write 1. We're just going to write x in the top, and on the bottom I've got 2 times z, which is 2z. Okay, so I simplified my numbers first. I made sure everything was multiplying, because I can't simplify without things multiplying, and then I simplified my letters. Okay, and then I had 1x in the top, I don't write 1, and then 2z on the bottom. Okay, in this example we have been asked to simplify 3b squared plus 12b divided by 5b squared plus 20b. Okay, remember, what you cannot do is you cannot just simply go b squared and b squared and b and b. We cannot do that because we've got this addition in the middle here. We've got nothing that is multiplying. Okay, so we cannot do this. Okay, so I'm just going to rewrite my question again. So it's 3b squared plus 12b divided by 5b squared plus 20b. Step 1 when we're doing these things is we need to see if we can factorise. So let's have a look at the top lines. We're going to have to do each, the numerator and the denominator individually. Let's look at the top line. Is there a number that divides both this and this? Yep. 3 goes into both of those. And do they have a letter in common? Yep. This has got b squared, this has got b. So in common they've both got b. Then inside my bracket, 3b times what is going to give me 3b squared? That's going to be b. 3b times what is going to give me 12b? That's going to be plus 4. So I've factorised my top line. Now on the bottom line, we're going to factorise. So the biggest thing that divides the numbers is 5, and the letters is going to be b. And then similarly, we're going to have b plus 4. Okay, so let's have a look here. Remember, when we have an expression in front of a bracket, that means that this is multiplying this. So this here is multiplying everything in here. So although that there's a plus here, it is being multiplied by this term here. This term is multiplying everything here. So let's see, what do the top and bottom have in common? Okay, so we've got 3b and we're multiplying it by b plus 4, and we've got 5b multiplying b plus 4. So they're both in common, they've both got b on their own, and they're multiplying, so I can cancel. And they're also multiplying b plus 4, so I can simplify those as well. What I'm going to be left with is just simply 3/5. Okay, that is the sort of method you should be looking for to do these sort of questions. Factorise first, and then see if you can simplify from there. Okay, in this example I've been asked to simplify 4a squared minus b squared over 2a minus b. So step 1, can I factorise? So let's look at the top line. Is there a common factor here? No. Is there a difference of squares? Do I have something squared take away something squared? Well, we can see here that I've got a squared and I've got a b squared. But if we recall back to our simplifying via factorising via difference of squares, we need to have something, this first term needs to be all squared. Okay, because only the a is being squared here. I need something to be all squared. So I can rewrite 4a squared to give me something all squared. So what times by itself is going to give me 4a squared? That is going to be 2a all squared. And then that's going to be take away b squared. And that's going to be over 2a minus b. I still can't simplify anything because there is no multiplying yet. Now thinking back to my difference of squares, at the top I've now got something squared, take away something squared. So I can write it in the form 2a minus b, 2a plus b. On the top now, I have got one term multiplying another term, because I've got two brackets next to each other, and I've just got a term in the bottom. So let's see if there's anything in common. Well, I've got 2a minus b and 2a minus b, so these can simplify, and I'm just simply going to be left with 2a plus b. If the expression was the other way about, if it was, for example, 2a minus b divided by 4a squared minus b squared, we would get something similar to this, except it would just be upside down. And if that were the case, we would have 1 over 2a plus b, but not to worry about that just now. Okay, last example, we've been asked to simplify x squared plus 3x plus 2 over x squared take away 4. So you cannot do this step here. You can't cancel x squared and x squared here because there's no multiplying taking place in either the top or the bottom line. So we cannot cancel the x squared and x squared here. Step 1, when we are simplifying algebraic fractions, we need to factorise the top and the bottom individually if we can. So let's look at the top line. We've got x squared plus 3x plus 2. Step 1, is there a common factor? Is there something they can all be divided by? No. Step 2, do we have a difference of squares? Do we have something squared take away something squared? No. So step 3, it's going to be a trinomial because it's got x squared plus 3x plus 2. So what we're wanting to do is we're going to have to put this into brackets. Make it black. Okay, so we need to identify factors of 2 such that when we add them together we get 3. There only is 2 factors of 2, it's 1 and 2. 1 times 2 is 2. So we're going to have x plus 1, x plus 2. If, for example, it was x squared plus 6x plus 8, we would have to identify the factors of 8 such that when you added them together you got 6 in the middle. If you're unsure about how I factorise that, just look back at previous videos please. Okay, so at the top we've got x plus 1 multiplying x plus 2. Remember, you can multiply out that bracket just to make sure you get the same as what we've got here. So I've factorised the top line, let's look at the bottom line. X squared take away 4. So is there a common factor? No. Is there a difference of squares? I've got x squared take away 4. So I've not got something squared take away something squared, but I can write 4 as a square number. 4 is the same as 2 squared. And now that I've got something in the form something squared take away something squared, I can then rewrite it as x minus 2, x plus 2. Now I've factorised my expressions, I can see if anything can simplify. So in common they've both got x plus 2 and they're multiplying, so I can get rid of them and then I will be left with, on the top, x plus 1 divided by x minus 2. Main things to note: factorise first if you need to. You can only simplify if things are multiplying together. If you're unsure of any of the factorising steps, look back at previous videos. Thank you.